Welcome back. I thought I would take a short side trip here and show you some test equipment you're going to need in the building of any project. First of all, yesterday I did a wellness check and everything's okay except some doctor somewhere said I have onset of dementia. So if I stutter, forget something, leave something out or whatever, let's blame it on that. Yesterday, I couldn't remember Mike Tarvin NQ7K's call and name. Monday night, about 8:30, I was in a hand at the table and I had an ace, queen of diamonds. I flopped 3 aces and got a full house and won $378. And if I can remember that, I think I'm okay. But anyway, at that time, I received a text from him with a picture of a SST board layout that I did some while back. I remember it, but I don't remember the date, so I have to look it up on QRP-Tech. So evidently I've gone through, we've done the SST before, but we did it with a printed circuit board. So just heads up, if I seem discombobulated, that's why. First thing you're going to need is a digital multimeter. This is an old one I've had for a while. You've probably got a bunch of the freebies from Fry's Electronics and $3 from Harbor Freight or whatever. These things are capable of measuring AC voltage, DC voltage. It's even got a millivolt level for low DC voltages. Then it has a ohm meter and a diode checker and a continuity checker. It also measures capacitance. I've never done capacitance with it. It's got a frequency meter, but it's not going to go very high. You can measure current. If you got the temperature probe, you can measure temperature. And there's an off on this side. So let me show you just a quick thing. Let me turn it on. Make sure you got batteries around the place. So I want to show you how to, using the continuity checker, how to test those pads we made. First of all, this thing, I need to put it in that's a diode, that's continuity, and when you short the leads together, you get a nice tone. So we made some pads, remember? Of course you remember. You got a better memory than I've got. We need a pad. After you make a bunch of Manhattan pads, since you're new, and maybe that's a new technique using the box cutter and the paper cutter, there's a possibility you might have little slivers of copper that short the top and bottom. First of all, check on your base plate, the continuities, make sure you're still getting the tone so you don't have to look over at the meter. Hear it? Now, touch each pad on the top, and if you don't hear anything, that's good news. So you just check all those, and I would check them again before I install them. I have a little habit of, and it's saved me many a time, measuring things before I use them. So that's one use. You need your multimeter. Good one would be a good investment. Secondly, we're going to be working with crystals, and I bought off of eBay, my mistake, one of these crystal checkers. This is a 3.932 crystal. You need a 12 volt supply for probably 9. This one does take 12 somewhere. Let me plug it in. Now it's going to be difficult for you to see the numbers without them flashing. Let me see if I can put a shadow on it. Whoops, can't do it. There we go. Anyway, it says 3.931 and then the last digit is blank. And that's because the vendor that did this thing, I got it off of eBay for $13. And the vendor is 52DZ DIY.com. Don't have to worry because they disappeared. The reason is they probably programmed this chip PIC chip incorrectly. It's a 16F628A, and the code is supposed to allow the extra digit, and I think there was a bug, and now it's fixed, and you can get it online. A German ham. This is testing my memory deal for something. Oh, there's an LY somewhere in there. Anyway, I've got another one on order. If someone would volunteer a PIC Kit 3, I can reprogram this thing, and then I'll do another project for you, and I'll give you a printed circuit board I'll show you. Okay, so test crystals. You can get them to, what, 100 hertz. Just make sure they work. It's a handy quick checker, but not your final go-to. Maybe just put it in a circuit and see if it works. Secondly, you need a frequency counter. Now the one that I use and will never part with is the old NorCal FCC1. And this was done in 2006. So this is 19 years old. I forget what the original price, I think, is $35. And it's good to 1 hertz. Runs off of 9 volts. And they made quite a few of them, I'm sure. Where's my 9-volt battery? Let me plug this in and show you how it works. And you'll need a way to calibrate it, or the way I do it is I purchased many, many years ago a thing called a GPS DSO. This is a GPS global positioning satellite discipline oscillator. You power it up. There's a GPS antenna which you put up against the window on the south so you can see the geosynchronous satellites and get most of the positioning satellites. And when you power it up, this alarm LED here is red. This one, hold still. Hello. Anyway, this little red LED will go out when it's in sync. This is, and I leave it on. I leave it on for a day or two if I really want to do something precise. And now I need to hook it up. Let me get a coax. Got the coax hooked up, and you can see that the counter's good to within a half a hertz or so. You calibrate it, but there's a Murata variable trimmer cap in the back. Bad place to put it. And going back to the PIC Kit 3, I can recreate this. I have the printed circuit board. I made the Gerbers, and I can program a 16F628, and we can redo this. I'll change the board so I don't need it for inputting IF and storing that and doing offsets and stuff, and makes it much more compact. Now, if you don't want to, just go on the internet, and there's from China these 8-digit counters that are LEDs, and I did a test on those way back eons ago, and those things are good from the factory. You can get them on AliExpress for under $10. On Amazon and other places, they go as high as 30. Don't do that. Next thing you need is a critter checker. I call this the Chinese critter checker. You've seen these. They're used to, you can measure inductance, capacitance, and transistors. Whoops, there's dust under there. I've been in the desert. Take any measurement with this thing with a grain of salt. For instance, let's do a transistor. Remember, I bought these transistors off of Amazon for $10.99. Let me back up. for $10.99, and I got 840. Now let's take a 2N3904. Now if somebody was having a bad day, whenever they package this kit, the 3904 should be right here. That's not where it is, it's down here. I'm going to take all these out and put them in coin envelopes. So it's an Easter egg. Now let me pull one out here. Close the lid, because you know what happens with open lids and lots of critters that want to escape. Let me take my handy dandy dome magnifier and make sure, yep, it's a 3904. Now this test is just to make sure, you know, it's an NPN and it's not shorted, blown or whatever. Put it in here, close this. It's going to look nasty because I've got LED bars and we've got the frame rate of the camera movie, and they're all going to flash. They say 8.85 on the battery, and there you see it's an NPN. The gain on this thing, DC gain, is 431. Now I'm going to make a little fixture and test that, and the forward drop base to emitter is 0.693 volts. Let me save this, and then the thing shuts off after a while. Put it back in its little handy dandy Dollar Tree container. So you need that. Oh, no, let's go on. Another piece of test equipment that I want to show you is you need a signal generator. Now, don't know what to tell you on this one. You know, where to get a cheap one, but this one's the one I use. It goes to 25 megahertz. It can do square waves and whatever, but I'm just interested in the sine wave. I measured the frequency with the FCC1 and it's off 115 hertz or whatever. But whenever I'm doing an experiment with this thing, I'm going to measure it with a frequency counter anyway. This thing's powered by 5 volts. It does USB stuff, and I just use it as a plain frequency generator. You can make your own, whatever, find a kit, and somebody will suggest some stuff. And now you need an oscilloscope. Now I have a Rigol DS1054. So it's a nice digital scope, and it's good to a very high frequency. I can snapshot, save things to a memory card for a display. But I have this old thing, and I looked online. They're over $200 now. This Handtech, and they're no longer made. DSO 2250. They want to say something else. It says it's good to 100 megahertz bandwidth, so 50 megahertz on a good day. But I love this thing because of the software, and I'll do a video on it. But you need a scope. Digital, if you smart enough, you can go to a Hamfest and find somebody that refurbishes the old Tektronix analog scopes. And we are down to the finale. Now I got Dave Breslev, AA7U down in Tucson, told me last week about this critter. This is a DE5000 LCR meter. Previously I was using LC200 and the AADE. The AADE, the almost all digital electronics LC meter, was the ham QRP standard for the longest time. The owner died, the business disappeared, nobody took up the kit or whatever. So for LC meters, the LC200A, which you can get, is fairly good. But this one you can get, look on Amazon, you can get it in 2 days. for less than 150 bucks, and you're going to get more. You're going to get a couple extra test leads, which I didn't get with this one, but it's okay. So let me power it up. The only thing that I do not like about this, oh, my picture, my face is in there. Ugly. Here we go. Power it up, and you have to calibrate. See, it's measuring. You have to calibrate it every time, and it's got an automatic power off that shuts it off every 10 minutes. So we're going to calibrate it. While you do that, you hit calibrate, hold it down for a couple of seconds, and it says open. Remove the test leads from here. You're going to put capacitors in these two slots here, and you hit calibrate. And it takes 30 seconds to go through here, and it's got a complex internal circuit that has to go and calibrate. And the specs, the manual says it's good to 0.3%. It's overkill for what we're doing, but it's available. All right. Now it says it passed, hit calibrate again. Now it says short, SRT. What you do now is you have to plug in the two test leads, short it, and then calibrate. Takes 30 seconds. I'm going to pause the video. All right. Finishes the test. It's going to tell me whether it passed or failed. It passed. So I get out of the calibrate mode, and it goes back to measuring, and it shows that these leads have a resistance of 0.008 ohms. So now it's auto detect. Let me show you this. I bought off of Amazon a set of disc caps. Now these things are not, some of them are C0G. They have a zero temperature coefficient. The rest of them are not. But I'm a fan of the monolithic caps, but I bought these because they're small and I just need them from time to time. They go from 1 picofarad to 100 nanofarads, and you got a lot of values that you can use. Now, you're going to poo-poo me and say, oh, to this, you know, for 10 bucks, less than 10, was 10 bucks or whatever it was, it's a waste of money. Let's check. So we'll go back to our trusty dusty meter. Let me just, now I did a one, the 100 nanofarad, the 100 nanofarad cap is one you use most, and it turns out in these they were all around 34 nanofarads. I threw them away. So, you know, you may get a bad set. Let's go and let's just pick a baggie. This is 25 picofarads. Open the bag. Let me throw one out here. It'll come out. Oh, here we go. Let's just stick this puppy in the test position here. I love the slot here. And it goes off and it says, now you can set the frequency at which you want to analyze it. This is at 1 kilohertz. Now that was 25 picofarads. It comes out 24.7. And the thing that you don't get with any other LC meter that I know of is the dissipation factor. And this is going to tell you how bad the capacitor is. The larger this number, the more likely at RF it's going to may cause you a problem. Not most of the time, not, but may. But this is a pretty good. You want it to be 0, and that's at 0.001. That's good enough. And it's 24.8, which means, you know, it's marked pretty well. Let's change the frequency up to 100 kilohertz. 24.84. The dissipation factor goes up a little bit, 0.003, but it's still within limits. And I go ask Deep Seek just how good they are. Let's try one more. Let's try. Okay, here's a 750. Let me take one out. Ta-da! what I say, 750 goes off. And dissipation factor of 0.008, that's pretty good. Value is 637. That's 13 in 600. That's 1 in 60. That's good within better than 2%. So I don't think you can ask for more than that. And since it's less than a penny for that cap, I'll use it. And it's good for 50 volts. Not that I'm working ever again with 50 volts. What else have I got to test? I can test some inductors and some other stuff, but the thing is fantastic. Especially, on inductors you can measure the Q, the quality factor. And that's where you want high values. So you can determine if your molded inductors that you got for 10 cents or whatever are any good and useful. Okay. Now there's some other test equipment, but we're gonna have to build it. And I told you I did the SST board a long time ago, and recently I did the G3 UUR board, and on it I put my little test fixture that I did for an article in QEX published by the ARRL some time back, and using some equations. In 1961 I started working with Dr. Virgil E. Bottom at McMurray College in Abilene, Texas. I worked on a project that was funded by HP, Collins Radio, and Knight Company, and it was crystal oscillators. I was measuring inharmonic resonance for disc quartz blanks with curvature, and measure as a function of curvature all the inharmonic modes, and a long time ago. I really appreciate going through that. I made $1 an hour in the lab. I was a lab rat. That's it. Did I show you? Yeah. That's it. See, I tell you, dementia is setting in. Thank you for your time. Do some likes. You'll notice that I wear surgical gloves here. It's just to keep my hands from getting cut or bruised or whatever, and keep you from seeing non-manicured nails and bruises from working in the garage. Okay, cutting boards and stuff. Enough. Blame it on everything. Thank you for your time. Come back, and please, likes again. I'm begging you. I'm a typical video vlogger. Thank you very I get all choked up.